Okay, so first, I'm going to show you the trick on changing these around. If you have a mixed number and it wants you to make it into an improper fraction, what you do is you take your denominator and you multiply your denominator by the whole number. So 5 times 3 is 15. So I'm going to write a little 15 over here, and then from there I add my numerator. So 15, 16, 17. 17 over, my denominator stays the same, 17 over 5. Okay? Same thing here. So with numbers with 6 and 1/4, I do 4 times 6, which is 24. I add 1, 25 over 4. Okay? Same thing here. 12 times 2 is 24 plus 1 is 25 over 12. Okay? That's making improper fractions. One last one. 10 times 2 plus 7. So 27 tenths. Okay? Now, if you could, you would simplify them. And we'll talk about that with our next lesson. Now, if I already have an improper number, an improper fraction, I have to divide to solve. And what I do is I ask myself, how many times can 5 go into 12?
Twice.
Okay, 5 can go into 12 2 times because 5 times 2 is 10. 12 minus 2, 12 minus 10 is 2. So I write my 2 up here. And then I bring back my denominator because that never leaves. If you're unsure if you did it right, check yourself. 5 times 2 is 10, plus 2 is 12. 12 fifths. So you can go back and do this same thing to your new number. So for here, 24 thirds. I ask, how many times can 3 go into 24? 8. Exactly, 8. So this improper fraction is actually representing a whole number. Cool. 32 thirds. How many times can 3 go into 32?
10.
Okay, because 10 times 3 is 30. What's left? 2 thirds. 10 and 2 thirds. Not quite sure? Check yourself. 3 times 10 is 30 plus 2 is 32. There we go. 20 twelfths. Okay, how many times can 12 go into 20? 1 time. 20 minus 12? 8 twelfths. Can I reduce that? Can I simplify that?
Yes.
Yeah.
1 and 2 thirds.
8 twelfths would become,
2 thirds.
so I would have 1 and 2 thirds. All right, so with that, we're going to move on to today's lesson, which is adding and subtracting mixed numbers. So, when I'm adding a mixed number, I start with the fractions. So let me show you what I mean. If I were to do 2 and 3 twelfths, and I were to add it to 1 and 10 twelfths, if I'm adding it, I want it to be stacked. I want it to be stacked. And I start with the fractions. So here's how I would set it up. 2 and 3 twelfths plus 1 and 10/12. So I've made it stacked, and now I'm going to start with my fractions. Notice I did not draw a line down here yet. I did that for a reason. Okay, and you'll find out in a minute why. When I start with my fractions, I'm going to circle them. And I'm going to add just those. What's 3 plus 10?
13.
So 3/12 plus 10/12 is 13/12. That is improper. I need to make it proper. I do that by dividing. How many times can 12 go into 13? Once. How much is left over? 1/12. I am going to take my new fraction, my new mixed number, and add it to the bottom of this problem. 1 and 1/12. Now, the reason I circled this was to show that I'm adding them, but also it now represents a big fat 0 because I have already added these together. They're done with. They're gone. They have been changed into this. They are now butterflies. They metamorphosized into a mixed number. That mixed number is this right here. So I don't need this. So nothing plus 1/12 is 1/12. 2, 3, 4. 4 and a 12th. So I start by stacking it, and then I go to my fractions. After I've add my fractions, make it a mixed number. Add and mix. You add the fractions, and then you make them a mixed number. Then you add new mixed number to your problem. And then you solve it. That's it. That's adding a mixed number. So let's do another practice of adding a mixed number. Let's do 2 and 3/5 plus 1 and 4/5. Remember, I'm not putting that line there yet because I still will have another mixed number to add. I start with my fractions. I circle them. I add them up. 4 plus 3? 7/5. Super improper. I make it into a mixed number. 5 can go into 7 once. What's left? 2 is my remainder because 5 can go into 7 one time, meaning 5 times 1 is 5, and 7 minus 5 is, so how that would look is if I were literally to do it like this. And that my remainder is 2. This becomes my denominator again. So 1 and 2/5 is my new mixed number. I now add my new mixed number to the problem. 1 and 2/5. Now I can draw my line. There's no point in these guys. Scratch them off. I've got my new number. 2/5 stays put. 2, 3, 4. 4 and 2/5 is my answer. Okay? Let's do another addition. How about 3 and 2/3 plus 2 and 2/3. Nice and stacked. Start with my fractions. I'm going to circle them and then add them. 4/3. Now I got to make them into a nice mixed number. 3 can go into 4 once. And how much is left? 1/3. I now add my new mixed number to the problem. These are no longer necessary. Draw my line. 1/3, 3, 4, 5, 6. 6 1/3. Okay?
Yep.
This is not something that can be done mentally here, guys. This part, yeah. But in all, you will super confuse yourself if you try and just stare at it and make numbers magically appear in your head. To me, that sounds like just awful. Don't do it. It's not worth it. You need to be able to write this down so you can see what's going on here. One more addition, and then we'll move to subtraction. Okay? Is that okay?
Yeah.
Okay. So let's try, let's say 1 2/3 plus 4 1/3. I gave you a nice one. Circle your fractions. 2/3 plus 1/3 is 1. It's 3/3, which is 1. So now all I'm doing is 4 plus 1 plus 1. 6. Ta-dam! Not bad, right?
Yeah.
Okay. Now let's go on to subtracting a mixed number. Step 1, when you are subtracting, write it as a sentence. Okay? Write it as a sentence. Meaning, if I'm doing 2 3/8 minus 1 7/8, I'm going to write it like this. 2 3/8 minus 1 7/8. Your next step is to improperize. Improperize. Improperizing is my fancy sparkle word for making something improper. Because look, 2 3/8 minus 1 7/8. This is just like subtracting from zeros. Can I subtract 7/8 from 3/8? No. This is too big and this is too small. So what I'm going to do is I'm going to turn them into improper fractions. 8 times 2 is 16. 16 plus 3 is 19 over 8. Okay? 8 times 1 is 8. 8 plus 7 is 15 over 8. Okay. What's 19 minus 15?
4.
So 4/8. Can I simplify? 1/2. Is that an improper fraction? No. So guess what? My answer is 1/2. So improperizing can get you to the answer, but sometimes it's not quite. So now let's look at another example of subtracting. 5 1/6 minus 3 3/6. Step 1, improperize. So 6 times 5, 30 plus 1,
31.
okay, 31/6. Now for my next guy. 6 times 3, 18 plus 3,
21.
21 6. 31 6 minus 21 6 is 10 6. Can that be reduced? Yes. To 5/3. Can that go down? Can that be simplified? No. Is that improper? Yes. So I need to re-properize. If answer is improper, then you need to re-properize. Meaning, how many times can 3 go into 5? Once. What's left over? 2 out of 3. I'm keeping that denominator. So now it doesn't quite match, but it is correct because it has been simplified. And that's what it asks us to do. Okay, so subtraction is a little bit more tedious. You kind of have to take it apart and put it back together again. But it sure does make it a lot easier. And it's not that this is super hard. 5 divided by 3, is that hard? No. But the steps are tricky to remember. So that's why we keep practicing it like this. This is one of those where the steps are going to trip you up if you're not careful with it. And that's why I'm making all these arrows. So let's do some more practice on subtraction, okay? Let's do 4 1/4 minus 3 3/4. What do I do first? I improperize it, so I do 4 times 4, which is 16. I can write that 16 off to the side if that helps. 16 plus 1 is 17 over 4. Now I do this guy. 4 times 3, 12 plus 3. Okay, 15 over 4. What's 17 minus 15? 2/4. Can that be simplified? 1/2. Is it improper? No. So guess what? I'm done. 1/2. Don't forget. Simplify. It's important to do that. Okay? So this is definitely one of the trickiest concepts that we will learn the whole year. Okay? So if this is tricky, just keep practicing these steps. Use your arrows, write your numbers, keep yourself organized so that there's no chance of losing your spot, because this is very easy to lose your spot in or forget what the next step is, okay? I did 4 addition, so I'll do 4 subtractions. So let's do one more subtraction to kind of get our bearings straight. 5 3/6 minus 2 4/6. Step 1, improperize. 6 times 5. 30 plus 3. 33 sixths. All right. 2 times 6. 12 plus 4. 16 sixths. Now I subtract. 33 minus 16.
17.
Over 6. Can that be simplified? No, it really can't. They don't share factors. It's not going to happen. So if I can't simplify, my answer is still improper. I need to re-properize it. 6 goes into 17. 2 times, because 2 times 6 is 12. 17, so even if you need to do this, you can. If you do 17 and 6 goes into 17 2 times. 2 times 6 is 12. 17 minus 12, 5. So I'll put 5 up here, and then this number, whatever you've divided it by, is your denominator. So 2 and 5 sixths. Can that be reduced at all? No. If this couldn't be, then this can't be. That's going to be just sort of the rule there.
Could it eventually be like you can keep on going? Like if it was like, if it was like 6 6, which it would be another whole, obviously. But like if it was, like if you don't have to have holes and things like that, which you obviously do, but would you like reduce the 6 6?
Well, 6 6 doesn't get reduced. 6 6 is a whole, and it would just be added to as a whole. Yeah. Remember, whenever we have a same numerator and a same denominator, there's no such thing as reducing that. 8 eighths cannot be reduced to 4 fourths or 2 2 or 1 1. It's just a whole. There's no reducing that. Okay, are we feeling okay about this?
Yes.
Okay.